Welcome back to Math 30-2. We're on the last lesson of Unit D, further graphing of log functions. So back in lesson 3, we learned about the characteristics of the graph that you definitely need to commit to memory. So exponential functions A and B, so depending on what that, so like A, for example, is going to be where it crosses the y-axis. B is it doubling, is it tripling, etc., the base. Lesson 4, we introduced the log function and learned that it is indeed the inverse of this function. And we learned basic characteristics of the specific graph too. Specifically, we worked on base 2. So in this lesson, we're going to further explore the characteristics. So now we're going to put a coefficient in front of the logarithm there. Okay, so review. Using a calculator to sketch a log function. Method 1, using the change of base. So if you don't have a 84 and higher, then you're just going to need to put it into the change of base, but it's really not that big of a deal. It's like a couple of more buttons that you have to press. So like if we're putting in log base 2, you just have to put this one right here. Like you don't have to worry about because this is this, right? This is the button that you're going to press. And so then you would just input this. So there's the exponential and then there's the logarithmic. Okay. And so you would want to set the window appropriately. Okay. And yeah, if you do have the log base feature, that just means you can substitute this directly in and you will get the same graph, okay? So go ahead and put this all into your graph and just verify that it does indeed look like that, and make sure that your windows are adjusted so that it looks exactly like that. Okay, so next page, exploring the value of b. Okay, so just like we did this for the exponentials, okay? So if we've got the graph of log 3x, the graph passes through the point of 1 and 0 and 3 and 1, okay? So there's the 1 and 0, there's the, oh, just kidding, there's the 3 and 1, so that one and that one, okay? And you'll note, so like if that was the table of values there, x, y, 1, 0, 3, 1. So if x is 1, okay, looking at here, if x is 1, we know we did the work that anything that had the argument of 1 was going to have the overall value of 0. And then same thing if we had the 3 here, okay, we would have y is equal to 1 if log is 3, because then it would be 3, 3, 1, okay? So that's the kind of pattern that we're gonna see. If we have 5, okay, well, these are all gonna go through 1 and 0, okay? And then these are all going to go through, so if this is 5, this is gonna be 1. This is 1/3, this is gonna be 1. This is 1/5, this is gonna be 1. Okay, and so then you could draw them. I mean, let's just put them into our graph, and then you would, I mean, we could still draw them though. You can put them into your graphing calculator, but let's just do this. So they're all gonna have the 1 and 0. So log 3, so we're gonna have the 5 and 1. I should have brought my different pens. So it's gonna go, I'm gonna try to like do this nicely. And this is gonna give me my, sorry, you know how I'm using just the one hand here. So y is equal to log 5x. Okay, the next one, so 1 and 0, and then 1/3. So that's gonna be here and 1. Okay, so that's going to go up like this. Oof, that was not good there. Sorry, gapped. Let's just put this in here. It tells us to put it in. Oh wow, whoever did this last was, okay, so y 0, so we're going to have log of, enter, so then log 5 of x, and then of 1/3, 1/3 of x, and then log base of 1/5 of x, and then let's see, we'll graph, and then, okay, so let's change our windows. Okay, and that's why I'm like, I need to be actually plugging this in here. Oh, and that's hard to see. So let's go to window, and it says here, so negative, we want -1, we want 11, we want 1, we want -4, 4 and 1, and so let's go back, and there, now we've got the nice diagrams. So what I forgot was when you've got a base that is the fraction, it's coming in from the other way. Okay, that's why I stopped there, because I'm like, wait a minute, something's not right. Okay, so yeah, we can see that so there's our normal, well, not normal, but a base with a number greater than 0, and then these two with our numbers between 0 and 1 are going to come the opposite way. And essentially what's happening is this is the same as writing like log 3 to the negative 1 x, right? So that negative 1 there essentially flips it. Okay, so then our point is still going to be there, but it's going to go like this and then come down that way. And then my 1/5 is going to be even smaller in here. So like there, and then still come through here and then go like that. So that would be my y is equal to log 1/3 x. This would be my log 1/5 x. Okay, and I should actually continue on like that and like that. Man, this is a rough start. Okay, so that's okay. We've got our diagrams here. Remember, you can do any kind of like trace if you wanted to go down and see, okay, like if x is equal to, what's that one? It's 1/5. So let's just go like x is equal to 10. Okay, and then, okay, y is going to be at negative 2.09, right? Or if I wanted to see, oh, will it not let me go to the, trace? It's weird that it won't let me go to the black one. Oh, there we go. I just need to do that. So then this one right here, say I wanted to know 9. Okay. Okay, well, there's the y value associated with it. Okay, so for our table here, so completing everything about the domain, range, x-intercepts, y-intercept, etc. Okay, so we know that for our first one here, so the log 3 one that was shown, this one right here, okay, we're gonna have a domain that's gonna be greater than 0, because right here we're gonna have a vertical asymptote. So XER, okay, and we actually see that for all of these, okay, it's going to be all real numbers. Okay, oh my gosh, I did it wrong again. Man, I feel like I should I don't want to restart this. I'm really sorry, guys. X is greater than 0, XER. Jiva. Okay, that's that. Range is going to be all real numbers because they're going in the positive direction, negative direction, all of them. So this is going to be YER. Okay, x-intercepts here, we see that they all go through 1 and 0. Okay. And then because they don't cross the y-axis, there is no y-intercept, so we say none. Okay, asymptotes, we know that there's a vertical asymptote at x is equal to 0. And then the x value when y is equal to 1, so that's the, like this right here, we see that it's always going to be equal to whatever the base is. Okay, so whatever the base is of that logarithm, that's when y is equal to 1. Okay, and then part C, state the base is the function whose graphs are increasing from quadrant 4 to 1. Okay, so increasing like that, we've got a base that's greater than 0, or sorry, greater than 1. Okay, so we've got a b that is greater than 1. And then the ones that are decreasing, these are the ones here, that's where we have a number between 0 and 1. Okay. All right, so there's the characteristics. Let's now look at A. Okay, so the characteristics of the A. This was the characteristics of, okay, what happens when B's are different. Now we're going to look at all the same B, just different A's. So you see here, we're all going to use the log base 3. Okay, so using the graphing calculator, so let's plug these all in. So let's do that, because last time I didn't do that, I made some boo-boos. Okay, so just plain old log 3. Well, we don't really need to put that one in because it's shown here. Okay, so let's put twice of log 2, no, just kidding, 3x, x, okay, and then I'm gonna have negative 2 math, and then how do I just put a? If I had my Inspire, I'd be able to do this quicker. 3x, and then I want negative 2, or sorry, negative 0.5, 0.5, and then all the way down 3x. Excellent graph. And there's my beautifully color-coded graphs right here. Okay, so let's get these more or less graphed out. So when I go back, so it always goes for the 84 CE, so it goes blue, red, black in order. So the blue one, that's my 2 log. Okay, so I see that it still goes through. All of them go through that x-intercept, okay? And then it's gonna be the different values. So if I look at here, so let's go trace. So if I go into, let's go to, or no, so I want, what do I want? Oh yeah, because it's a base 3, so I want 3, okay? So base 3, I've got the coordinate point 3 and 2. So I'm going to plot that 3 and 2. Okay, and then I know that it's going to go through the intercept there. So it's gonna go like like this. And then if I put in, what happens if I put in a 6? Okay, nope, 9. There's my 9 and 4. Okay, and so if I go 9 here, and then 4 is gonna be here. So I know that it's going to go like this. Yeah, that was bad. There we go. We'll pretend that's a nice smooth line, and this is why you should do things in pencils, folks. Okay, so this point, all of them are gonna have the point 1 and 0, but then this one right here, y is equal to 2 log 3x, is going to, and so if it makes sense, right? Because it's stretched by a factor of 2. So these ones right here, so this was 3 and 1, this is 3 and 2, this is 9 and 2, and this is 9 and 4. Okay, and so yeah, it's all because it's based off of, like, if we look at this, if we put this to the power law, one of the ways of thinking about it, I think, would be if I put x, and so like it's squared. So then if my x is, so I did the 3, right? I put the 3 in there, so then it's going to be equal to 2. If I put the 3 in there again, or sorry, the 3 squared, now it's going to be to the 4 there, right? Because it'd be 2 times 2 is 4. Okay, so it's just the log laws again. So then this next one here, so the negative is going to be the exact same as this graph, except for it's going to be reflected. Okay, so then it'll be like this, and that's the, oopsies. Oh no, wake up. What did I just do? I think I just messed with my, oh, hey guys, it's Friday the 13th. This is why it's happening. That, and obviously. Okay, whatever. It's going to be opposite here. So it's still going to go through here, okay, and it's going to come, and it's going to, and we're going to draw this the best we can. Okay, see, and like this part right here shouldn't go down, right? It's not like it's going down and up. This should go like that. Okay, so that's the y is equal to negative 2 log 3x. And then our last one with the 0.5, same thing, it's gonna be down here, but now it's going to be, so like this is the like normal one, like without anything in front, like a is equal to 1, I should say. And so this one then, it's gonna be half the distance there, and then on the flip side, so then at this point here, it would be there. And you can like verify this with your calculator, obviously, and not perfect, but good enough. Y is equal to negative 0.5 log 3x. Okay, we done did it. So now if we see here, so are there any differences? If the base is between 0 and 1, and then investigate using your graphing calculator. Okay, so if we go back to, okay, well, I'm gonna have to put my window back to this. So let's just quickly do this. 11, 1, just negative 4. 1. Okay. And waiting. Come on. Okay, so now I'm going to put one in. I'm going to put in, so just, let's put in, so 2, because I'll do this one right here, and then log of 1/3 of x. Okay. And did I do that right? Twice log base 1/3 x. That's what we wanted to do, right? If the base, investigate. Okay, so let's just move my window out a bit. Wait, purple. Oh, it's right there. It's the same as this one right here. So it rewrote it from the red one. So 2 log 1/3 is the same as -2 log 3. Okay, so -2 log 3x is equal to 2. I actually did not do that on purpose. The thing that you should say for whenever your b is between 0 and 1, that it's going to be going down. It's going to be decreasing from quadrant 1 to 4. Okay, but we do see this relationship here, and so once again it has to do with the fact that this right here can be written as 3 to the -1. So in 30-1 we go into this a little bit more and how this equates, but if you could just remember that if we do have a fraction here, it can be written as the reciprocal power. It's the same as bringing a negative out there. Okay, so then here's the overall, like what's happening with the graph characteristics there. So if we have an a that's greater than 0, okay, so that's like this a is equal to 1, this a is equal to 2, we see that they're increasing, okay? The graph increases from quadrant 4 to 1, okay? And then it's the opposite, okay, for these ones, okay? If we had a negative, okay, so a negative value, it's going to decrease from 4 to 1. Decrease from, did I say that? Decrease from 1 to 4, 1 to 4. 1 to 4, cool. Okay, and then if I have the fraction, so that's like what we did over here. Okay, so if my base is the fraction, but a is positive, like all of these ones here, okay, I see that they were decreasing from quadrants 1. So decrease from quadrants 1 to 4, just like that one, okay? And then when I had the fraction, but did I do a fraction with a negative? No, I didn't, did I? So that's less than 1 and a fraction. Oh no, there's my a is negative. So that's this one, sorry, that's this one here. Oh, no, I didn't. Okay, let's do one. Let's do it. I mean, hopefully you realize it's going to increase from 4 to 1 because of the relationships here, but that's okay. So we need to do a -2, so -2, and we need to do a log of 1/3. Okay, and then x, and then so that one's going to be green, and so we see this one turns green. Okay, so then, but there's our increase from 4 to 1. Okay, and then that's our other, like, so I wrote in, let's just look at those again. So if I go there, so my blue and my green are the same, okay, and there's that negative right there again. So if I have, so I'm just gonna write it down here. So if I have the -2 log of 1/3 x, that is equivalent to just 2 log 3x. And it's because basically these two negatives, like this as 3 to the -1, -1 times -1 is a positive. Okay, so fun things with symmetry and relations. So here is so just summing up the characteristics here. So anytime we have a logarithmic function with an a in front, okay, and then of course, as always, b has to be greater than 0 and it can't be equal to 1. Okay, the x-intercept is always going to be equal to 1. Okay, x-intercept is going to be 1 and 0, right? But x-intercept, and then there's no y-intercept. It does not cross the y-axis. The domain is going to be, so x is such that x is greater than 0, and x is all real numbers. Put the fancy. And then the range is going to be y is such that y is all real numbers. Okay, the y-axis is going to be a vertical asymptote, with equation x is equal to 0. Okay, and then all of this right here is from this graph. Okay, so this is the first one there. A is greater than 0, b is greater than 1, so it's increasing 4 to 1. Okay, so the graph increases from quadrant 4 to 1. Okay, and then the other example, it went decrease, increase, decrease. I should double check that. So negative and greater than 1. So negative and greater than 1, decrease. Yeah, damn it. Because they're like the opposites. So this one's going to be decrease and increase, because these are the two that have the like similarity. And then these two. Cool. Okay, and then just a reminder about how the logarithm is the inverse of that exponential, and that b is both the base of the logarithmic and the exponential. Okay, so state the inverse of the following function. Answer in the form of y is equal to whatever. Okay, that's weird that they have us doing this again. But that's okay. So we want to, so it's going to be 3 raised to the power of y is equal to x, okay, and then we would just interchange, so y is going to be equal to 3 to the power of x, and then this one here, so this is going to be log, the base is our base, and then eventually, so changing, it's going to be y is equal there, okay, and then what are we doing with these? Which of the graphs below could not represent a function of that? Okay, so any of our graphs here looked like that or that, not this. Okay, this one is showing that there is a horizontal asymptote, which does not match. Okay, cool. All right, that was a rough one. I'm really sorry, but hopefully you understood it enough to do the assignment. Cheers.